So in order to configure IPv6 in our environment, we have to use Dhcp with prefix delegation. Okay, we have to request a /56 address. Now the idea is that when we use IPv6 network, we usually have a /64. So the idea is that we are left with 8 bits for subnetting our networks, right? Remember, in order to have 56, we have that 3 extents are fixed. Okay, each of these is 16 bits. The last one, that is the one that we need, that will be split in 2 nibbles. Remember, so remember in 2 bytes. Sorry, the first byte will be sent by our internet service provider. Okay, so this will be our prefix that we receive from the internet service provider, and we'll be left with 8 bits to play in our network. Okay, for subnetting, and we will have 2 nibbles, right? Meaning 2 hexadecimal values. Okay, in our case, I'm using ACME 90. Okay. So in my case, I will receive something where the only so this will be sent by internet service provider. The last 8 bits will be simply the number 90 in hexadecimal representation. So in my case, will be something like 5A. Okay, and I will have to play with the left 2 hexadecimal letters. Now, the idea is that how do we assign our IP subnets to our environment? Okay, so remember, we will receive a wall network. So this will be our address space. It will be a /56. That we can further subnet, right? So we will take the full network, we will split in several pieces. Okay, and now the idea can be that we reserve half of the space or maybe part of the space to our main environment, and half of the space to the internal firewall. Okay, so since we have a /56, we will have that so our space will be again so 5A00. Okay, so we will split it. So the first half will be 5A00, and here we will have 5A80. Right? Here we have 5840, and here we have 5AB0. Right? So this will be the space. So we'll do all the assignment. Instead of using ACME 90, we will use ACME 24. Okay, as you can expect, 24 in hexadecimal number is 18. So 18 will be the subnet, that the prefix that we will receive from our internet service provider. So as you can expect, all this space here will be, instead of 5A, will be actually 18. So we will have 1800, 1840, 1880, and 18B0. Okay, so this half will belong to main, this half here, and this half will belong to internal firewall. Okay, then in order to make everything to be compatible and to be in some way related to the original IPv4 addressing, we will also match the numbers that we have in our IPv4. Now, one last thing that we have to recall is that the network that we received is a /56, and if we split in this way, all the so the 2 spaces will belong to the different firewalls. So it will be all of these networks that we assign will be a /60. Okay, but if you remember, the network that we will use in IPv6 are always /64. Okay, so we have to use both hexadecimal number, but for now we can focus only on the first /60. Then we will keep for the main, so we start from 18, and we can, if we enumerate all the possible networks belonging to this /60, so you can imagine they will be 1800, 1801, 180F. So if you notice this, so the first hexadecimal will be always 0, and the only hexadecimal that will see, the only hexadecimal digit that will change will be the second. Similarly, in our internal networks, we will focus on 1880, and this will be the network, so this is the /60, and if we enumerate all the networks /64, we will have again something like this. Okay, so the number that we will play with for the network will be this one. Okay, so since we want to match the numbering in IPv6 with IPv4, we will have that for the DMZ, we will choose the network that will be 18.0 because it belongs to the main, 6 because is the DMZ, and the DMZ has the 6 for IPv4. The external client network will be 18.04. Then the in the main the network between the point-to-point network, that is actually 254, will be the last network that we can use. So this belongs again to the main firewall, so we will use 18F. Then for the server network, since we are in the internal, so the network that are operated by the internal, we will use 18.8.1, so the same number of IPv4 but 8 because it belongs to the internal. And for the internal client, we will use 18.8.2, okay, because it's the internal client. Okay, now the last thing that we have to do is that we we have to realize, similarly to the delegation process that we have from the ISP to the main firewall, we will replicate exactly the same behavior, and we delegate the network that we are assigning to the internal firewall from the main using Dhcp. So we will start a Dhcpv6 server on the main, and we will delegate the /60, all the network /60 we will delegate, so as /60, that will be exactly 18.8.0. Okay, one single /60 that will host all the network in our internal firewall. Okay, so this is our plan. So those are the networks we want to realize. Okay, and then this is what we will do in our environment. Okay, so let's go. Okay, so we have to start connecting and configuring our IPv6 addressing. And we start with our client, external client on the external network. First thing we do, we can check that we don't have any IPv6 address, but only the link local address. So we check it like this. We can see that we only have IPv6 on link local. So we start connecting to our firewall. Remember, since we are in the external network, we can connect to our external interface on the firewall, and this is the address. So the first thing we use, the user and password. Okay. Okay. So the first thing we check in the interfaces, we can see that we don't have on the in the interview overview, we can see that no interfaces have an IPv6 address. Okay, so it's completely unconfigured. Okay. Also one in. Okay, so how do we do? For every interface, we have to configure. So let's go on the one. The first thing we have to do, we have to request an IPv6 address using prefix delegation. So the first thing to do, we go on configure via Dhcpv6. Okay, so we don't want to request only the prefix, but we also want an IPv6 address. According to our requirement, we need to ask for a /56 prefix. Okay, and we keep it like this. Okay, so save. We can apply the changes. And if we now go on the overview, we should be able to see that the one interface received an IPv6 address. Actually, received two of them. FD00, if you remember, this is a unique local address, if you remember the definition of this. And then we receive an IPv6 delegated prefix. Okay, as you can see here, we received B5, so 2001 470 B5, B8, and 18. Okay, 1800. If you remember, the 18 is the one that we received from the ISP, but also the 200 here is the space that we can use for subnetting our networks. As you can check, the 18 stands for in hexadecimal is 16 plus 8, that is 24, and that's why I'm connecting ACME number 24, okay, as we were supposed to do. Okay, so now we can move and we can configure the other interfaces. So let's start with the DMZ. If you remember, we decided to configure using SLAAC, so stateless auto address configuration. So with the OpenSense, we can use the track interface so that we can announce everything on the so we can keep one of the network that we received from the prefix delegated prefix. Now here we can choose the sub network that we want to use. Remember, we decided to use all the so we split the prefix that we received in two. So if we have a 0, any number between 0 and 7, we are considering a network delegated and used by main firewall. If we have any number between 8 and F as the first nibble, we are referring to prefix that is managed by the internal firewall. Okay, so we choose 06 because we want to map with the same address and address space of the IPv4. We click save. And apply changes. And now, if we go in the overview, we can see that the DMZ network now has an IPv6 address that is taken from, so this is the prefix delegated, and this 06 is the subnet that we are considering. Remember, all the networks are /64. Okay. The same can be done with the external client, where we have our, for example, our Kali network. So we can do exactly the same. So track interface, we choose 04, save, apply changes. Done. And now if we go here in our IP and we ask for an IP address, okay, after some seconds we can see that we start receiving some router advertisement And in particular, with the Kali configuration, we are considering, so we are receiving several different IP addresses. Okay, so this is a like a static IP address. This is considered a global temporary dynamic, and this is a global dynamic management non-prefix rule. Okay, so this is the usual UI64, and this is the temporary. Okay. And now the idea is that we will choose one of these to be used inside our DNS in the following. But for now, we only have to configure the IPv6 addressing. Okay. So we are done, almost done. So when considering the internal interface, what we have to do, we have to apply a different approach. Okay, so here we have to start using the again the track interface, but we also have to use a Dhcp server in order to further delegate our IP address, some of the prefixes, to our internal firewall. Okay, so what we have to do, we have to again choose a track interface as before, but now we have to allow for manual adjustment of Dhcpv6 and router advertisement. Now, as you can recall, we decided to assign a specific prefix here that we decided to use the last possible network, always keeping the 0 as the first nibble. So we decide to set F here. Okay, save, apply changes, and there we are. So now if we go again on the overview, we can see that our internal interface has taken a prefix that is the one that we specified, but now we can go in the services section, and we have to configure the internal. Now we have a section that is related to the internal to router advertisement that we want to send in the internal on the internal link. Okay, so we don't have to disable, so we want to, okay, if you click on this informative button, you can see the different values that you can give to this router advertisement. In our case, what we want to do a stateful Dhcpv6. Okay, so we want to select or to send in our network so that we can give and assign a delegated prefix. Okay, so in our case, we have to select managed. Okay, so let's select managed. Okay, be sure that we have advertised default gateway, because we want to use our this firewall, so this router, as the default gateway, and then we can go and click save. Okay, now next step, we have to configure the Dhcpv6 server. Okay, so let's go on the internal, and now we have to enable the Dhcpv6 server on the internal interface. Okay, so this is the prefix that we are announcing in our in this link, remember, because we got an IP from this network. So this is the range that we can assign. If you remember, we can decide the IP that we want to assign to our to the other host. So we can really decide the type of the address that we want to give. Now, if you remember, in our setting, the number that we the IP that we assign is a fixed one. So for example, we can assign the number for example, 2. Okay, so we only want to provide one single address, and this is. Similarly, we can delegate the range that we want to give to the internal. In our case, we want to delegate only network that starts with 8 at the beginning. Okay, again, if you want to understand a bit more about this setting, you can read the suggestions and informative button here. Okay, so since we are using a delegated prefix, we have to only specify the network that we want to assign. Okay, so in our case, we only want to send the network that starts with 8 and ends with 0. Okay, so this will be the network that we want to give. Okay, and we will send a /60. Okay, one single network is a /60. Remember that since it is a /60, it will be all the networks that belong to 8 and any possible number at the second nibble. Okay, so it will be 16 networks of size /64. Okay, and that's it. So let's save. And it's done. Okay, now we have to go on the internal firewall. Okay, to go on the internal firewall, we change the IP address, so it will be 100. Sorry, 100. Yeah, we can go on one or any of the internal interface, for example, number 2. Okay, as usual. And there we are. So as you can see in the name here, it's internal firewall. Okay, so I will show you then in another video how we can further distinguish between the different firewalls. Okay, so first thing to do, let's go on the interface. Remember that in this internal firewall, the interface that is facing the external, the main firewall is the external one. Okay, so let's go on the external, and as we have done for the main firewall, we do exactly the same. Okay, so we want to receive using a Dhcpv6. Now we want to ask for a /60 prefix, and that's it. Save. Apply changes. And now if we go on the overview, external, we should see that we have the link local IPv6, we have the IPv6 address that we set in the possible prefix. So this is, remember, is a network managed by the main firewall because it starts with a 0, and then it's the only address that we selected, and then we can see that we also received a delegated prefix, and as you can see, this is exactly the network that we wanted to be managed by our internal firewall. Okay, now we have to do exactly the same that we have done for the other. Okay, so let's start with the server network. We use IPv6 tracking. There we go. So if you remember our the assignment that we wanted to give, we want to do exactly one single value, so we use 1. Remember that we are keeping the subnets from a /60, and then since it is a /60, the only size that we can decide is one single byte, so only 4 bits, so we only use one hexadecimal value, and in this case is 1 as the network that we are using. Okay, save. Apply changes. done. We do exactly the same for the clients. Track interface. Network is number 2. Save. Apply changes. And there we go. So let's go on the overview. Now we can see that the client, so remember this is the internal client. So the IPv6 address is taken from, as you can see here, the 4th exit is 82, so it's managed by the internal and is network number 2. Okay, if we go in the server interface, it's again is network 8, so starts with it's managed by the internal firewall, and it's network subnetwork number 1. Okay, now there is one last thing missing that we have to properly configure, is that we have to enable the traffic to flow also for IPv6. Okay, so we have to go in the rules. Okay, now check all the rules that we have in our firewall. So floating is nothing. So for example, in the client, we only allow any IPv4 traffic. We have to modify this in order to also allow IPv6, like this. Okay, save. As you can see now, the rule has changed. We have to do the same for all the rules and for all the interfaces, so that we can allow any IPv6 traffic to flow. Okay, remember that then we have to enforce the policy that we have in our assignment. Okay, but this is only for properly configure IPv6. So we start from a full open network. Apply changes. Okay, we do exactly the same in the main firewall. Tools, DMZ. That's the So we repeat this for every internal. Okay, apply changes. Okay. Okay, now that we have set up the internal exchange, we have to check if everything is working. So if we have full connectivity, the first thing that we do, we go on the internal firewall and we check that everything is properly set up. So what we do, system, we go on routes, we see the status of the routes. So we check if we have the IPv6 networks. As you can see, we have a default gateway for the IPv6 traffic. We also have several internal networks. As you can see, /64, and you can see where is the gateway for all the networks. So this means that we have network 18.0f, 18.81, and 18.82. There are different networks for our connected to our interfaces. Okay, now we have to see if we have full connectivity. So we will connect to 2 different hosts in our network, and we check that we can ping each other. Okay, so let's start. For example, we go in the DNS server, so it is in the internal server network. We check the address, we select the address, then we can go in another host, for example in the web server that is in a completely different network, and we can try to see if we can ping the host. And we can see the time to live is 62. It means that we have to cross 2 networks, and we can see that we have the connectivity. So we can also do the same from the other side. Oh, sorry, the IPA. Okay, so this is the web server, so this is in another network, so we can select the IP address, sorry, like this. We can go okay, and again we can see that in the same network we only cross 1 network. Okay, one thing that we can observe without IP address is that in our case, for example, Kali is always using the it's using the temporary dynamic, but also is using the UI64. If you remember, we can also opt for a different type of connection of address selection. So, for example, we can switch from the EUI to the, remember, stable privacy. The stable privacy is a different type of addressing generation that is stable with respect to the prefix that we are using, but it's in some way not so it's hiding also the MAC address. So in some way it is completely unrelated apparently is unrelated because it's in some way generated manually, but with a pseudo-random function. Okay, so for example, we can select a different generation mode, stable privacy. Okay, save. Okay, we can close. And we reconnect the network. Okay, and now with IP address, we can see that we don't have anymore the UI64, but actually we have a different generator. And as you can see, also in this case, a dynamic management address, non-prefix route, but this is not really related to the UI64. Okay, and this is the one that we will use in our DNS server. Now the other one is the temporary dynamic. If you remember, the idea is that when we want to connect somebody, we will usually prefer to use this IP address. When we are receiving from the outside, we will usually accept connection on this that is in some way stable from the point of view of the connection. Okay, if we want to do the same in our web server, remember, so if you don't want to have also in this case an UI64 address, that is this one, sorry, this one, this section, so the ID, remember that we have to use the sys control, remember, so we should use the address generation mode, remember. So remember, it is we have to search for address gen mode, okay, in the network section. Oh, GTL, sorry. Okay, so 0 is the standard, so we have to change it in, if you remember, number 3. Okay, so sysctl, we write the new value, it will be address generation mode, will be 3. Okay, now if we check, so we have to we can see that it's still the old one, so we perform if IP a flush no IP ATH down EDZ. Set up. And now, as you can see, again, so once we receive the and we choose the IP address, so this is still a tentative, remember, so we start DAD. If we run it again, the tentative should be done, and now we have the dynamic scope global dynamic, and as you can observe is a stable privacy. Okay, so we can repeat the same for all the addresses, and the idea is that these GUA addresses will be the ones that we will use in our DNS server when we will do it right now. So if you observe, this one will be lost if we machine, because remember system control is just a temporary. So if we want to make it permanent, we have to modify the system control configuration. Okay, not only there is another caveat that we didn't mention. If we keep the value with address generation mode 3, if you remember, this goes and checks the variable state secret that is set configuration, and if it's not set, it will use a random value, random secret. This means that every reboot will be generating a different IP address, and this is not what we want. So we need to only set the address generation free, but we also have to specify the stable secret value. Okay, so in order to do this, we have to edit, and this is the local file where we are supposed to change our value. Okay, and then we modify exactly the same value that here. And we also set the stable secret. Okay, this is, and there we are. So configure the stable secret. Okay, this should be a random value. I just for our publication. So give it. And now if we reboot them, when it's back, check again our address, you can see that is only a privacy, stable privacy. Okay, so this will be the address that we will use in every other host as our IPv6 DNS address, in addition with the IPv4 that 100.102. Okay. So first thing to do, let's install dnsmasq. Okay. Fp it like this, of course. Apt install dnsmasq something. Okay, it will complain because we already have with the Debian standard, we already have the system resolve service, but we will fix it during the configuration of dnsmasq. So for now, don't mind too much. Okay. So the first thing to do is just to copy the dnsmasq original configuration in a file that we can use later on as original. Okay, then we just have to edit the configuration of dnsmasq. Okay, you can spend some time in looking at all the configuration file, all the details of the configuration, but for now we can just go to the straight to the configuration. I will just move on the setting that we need to change. Okay, so let's start with bogus private is just that we need to see. Then let's scroll down. Oh, sorry, sorry, I don't want to do this. Okay, then so this is the network that we want to serve. So a local domain. So in my case, I just want to provide acme24.test. Then we just have to see the interfaces that we want to list. Oh, okay, the listen addresses that we want to serve. So this has to be a public address accessible from my internal networks. So I will configure all the details, and now I need to include also the IPv6 address. So just copy. Okay. There we are. I think I copied twice. Too much. Okay, there we are. Then we just don't want to use also the Dhcp interface. Okay, so we just want to use the DNS. Then we need two extra settings. This one is to resolve the configuration issue for the when it complains on port 53. Then we want to expand the hosts with our domain name, and then the only thing that we want to expand is our domain name. Okay, so we just add acme24, sorry, acme24.test. Okay, let's say X, and now we can try to restart our dnsmasq. So system yeah, start dnsmasq service. Okay, let's see why. Sorry. Oh, there is an error. Oh, let's see, maybe there is something. at line 111. So let's go and check. Okay, go to line. No, doesn't work. Sorry. Here. Ah, okay. There is a missing comma. Okay. Okay. Started. Now, what we need to do. Okay, so just to be precise, we want to just show what we have changed in our file. So just grep. So anything that doesn't start with dnsmasq.conf number. Okay, those are just the lines that we changed. Okay, so it could be useful just to keep in mind. So now that our DNS is configured, we have to just collect all the addresses that we want to provide to the host. Okay, so for this purpose, we have to just fill the etc hosts file. Okay, so we just have to collect and fill this table with all the IPv6 addresses and also IPv4 addresses that we want to provide to our host. So far what we have is just our DNS server ACME. Okay, and we, for example, we can add ourselves. So we could also include, sorry, as usual, IPA. We just copy the IPA. Okay, we just write it again too many times as usual. Okay, this is DNS server ACME 24.test DNS server. Sorry, this should be a dot. Okay, so now the idea is that we have to do exactly the same for all the hosts, like for example web server dot acme 24.test. Okay, so let's try to get it. So let's go in the web server. Okay, IP address. Okay, we can see that again we have the EOI 64, so we should change also in this case with the system control. Okay, by the way, for now let's keep it like this. Okay, we just select. Okay, then we can repeat the same for the IPv4 address. Sorry. Okay, so the IPv4 clearly is 100.100.6.2. Okay, then we can repeat it also for the other hosts. So for example, we could go on the external client. So let's go. So let's see. Okay, we have several temporary that they don't make any sense. What we do really need is our the one that is generated and with the stable prefix. That should be this one. Okay. Okay, so this is clearly client X1, client X1 on Acme 24.test, and for the IPv4, so 100, 100, 400, and there we are. Okay, so we restart the DNS server, and we have done. Okay, so now if we go on the web server, we can do host, or maybe, okay, host, let's say DNS server, for example, 100, 100 to 1, sorry, 1, 2. So we are requesting exactly this, but we can also request using a IPv6 host. Okay, DNS server. Okay, we can also ask for the, for example, client X1, and there we are. Okay, now the last thing that we need to do is to make this value, this host to be used in resolve.conf. So for example, we could write cat equal okay, so now we can also do ping. Okay. We could also, for example, insert in our connection. So edit connection, we can just add this new DNS. So in any case, additional DNS servers. And also here, we can take, for example, okay. So now if we connect again, okay. So example, we can try to ping web server. Okay, so we can repeat this setting. So we can just fill the idea is that we can just fill the file with all the IP addresses of our host in the network, and we have done.